Hello and welcome to part 2 of my IBM 5155 video, and as you can see it has been assembled almost completely, casually drawing up an office space in AutoCAD 2.6. And yes, this is a disassembled Model F keyboard, more on that later. So in this video we'll focus on a broken floppy drive, a defective hard drive, a leaked battery on the memory board, a broken video card, and a damaged memory card and broken keyboard. So in the last video I showed you our IBM 5155 booting from the hard drive, but there were some issues during that boot process. Just take a listen. Now that doesn't sound particularly good. So although I was able to continue and load up the folder structure of the drive, I wasn't particularly confident that this drive would work as is. So on startup and while launching applications on the hard drive, I got lots of errors. I got these data errors, sector not found errors, so there was obviously something wrong with the hard drive. The hard drive was also making these strange noises that was very worrisome, so something needed to be done about it. After hitting retry long enough, it did eventually continue. But just to show you what was installed, it had the IBM Fixed Disk Organizer, which is kind of a menu system for MS-DOS, and it had WordPerfect 5.0, 4.2, it had the Lotus Symphony Suite installed, it had Foxbase installed. So yeah, some basic applications from the XT era. I was able to start WordPerfect, but as soon as I tried to save a document or exit the application, I again was confronted with the hard drive errors. So at that point I decided to start with my MS-DOS boot floppy, enter the debug session, and start up the low-level format routine of the Seagate card which is installed, which provides you with this nice little menu here. So the low-level format routine asks a couple of questions, and it says that the drive 1 is an ST138R, which is a 30 megabyte RLL hard drive. Now at that point I had no reason to doubt this information, as the Seagate was in fact an RLL controller, but I didn't really look at the hard drive itself, which was in the computer. So I specified an interleave for the formatting, opted not to enter a defect list, and started the formatting process. Now the low-level format takes about 2 minutes, and it completed without any noticeable errors. After the format, the low-level format routine from Seagate also does a verification. This takes about 4 minutes, and also there no errors seem to be popping up, which was nice. So after a low-level format, obviously you need to boot into MS-DOS again, set up your partitions using fdisk, and execute the format command. Now because we have issues with the memory card and we only have 256K of memory, we cannot format and transfer the system files in one shot, so I'm just going to be formatting it and then copying the system files. The observant viewer will have noticed that it didn't accept Y as an answer, and this is because this is in fact a French MS-DOS boot disk with English MS-DOS command files on it. So on all these prompts you need to use the French word oui, which is yes, so you need to type O instead of Y. But to my surprise, the formatting completed without any errors, and we had a full 32 megabyte of available disk space. No bad sectors, everything was looking good. I then continued to copy the system files over to the hard drive so that I was able to boot from the hard drive. Again, notice how it displays it in French because it's a French boot disk. And after a reboot, the hard drive had no issues starting and loading up the MS-DOS prompt. Now I was using a spare floppy drive to boot into MS-DOS, and I wanted to get the internal floppy drive working again. So let's take a look at that. So let's see what happens when we plug in the floppy drive and try to start the machine. And the following happens. So we switch it on and nothing. So that's not good. So let's disconnect the floppy drive and try again. Aha! The machine decides to start when the floppy drive is not connected. So this indicates that there must be a short somewhere on the floppy drive. Now the floppy drive controller in the machine works fine because I had been using up to this point a spare floppy drive to test the controller and to install MS-DOS to do the partitioning and formatting. So all of that seems to work fine. So let's focus on the floppy drive itself. So let's take our multimeter and poke on the 12-volt rail here, which is very error prone. And indeed, we have a short here. Now this is something that is fairly common, that these tantalum capacitors go short circuit, causing the power supply not to start. Now, to get to the floppy drive, we need to remove a lot of screws, and a lot of different screws, like all screws here on the IBM 5155. So we're going to be using this hex tool to get the screws out. The screws on the other side of the floppy drive are even more difficult to get out. So this has got to be the worst PC ever to disassemble. Even as something as simple as a floppy drive just takes a whole lot of effort just to get it out. And there are these big screws here all over the place, different sizes, different types. It just drives you crazy. So now we're on to the last two screws here to free up the floppy drive. So let's go ahead and remove those. And then the floppy drive should just slide right out like so. And now we can take a look. So we're going to be removing all of the connectors here because I want to free up the printed circuit board of this floppy drive. And after removing that, the PCB can be freed up and we have easy access to it to take a closer look. So here on the power connector we have two tantalum capacitors, and we have already determined that one of them has gone short circuit. Or at least that's what I thought. So I decided to just blindly go ahead and desolder the capacitor, which I thought was faulty. So I just used my desoldering tool to remove all of the excess solder, bend the pins up straight so that I could easily remove the capacitor from the printed circuit board, hoping that that would remove the short also. Now these tantalum capacitors are very error prone. We already saw that on the main board, on the CGI card. I don't have a replacement for it, but this electrolytic capacitor should do the job also. But the short was still there even after removing the capacitor. So what you need to know is that this 12-volt line goes all the way through this line filter here and then continues on the bottom of the board. And there's an entire 12-volt rail here also. So following the path here. And there are two additional capacitors on this 12-volt line that could also be short circuit. So let's recap a little bit. So here we have the 12-volt rail starting on the top from the power supply through the line filter, and on the bottom it follows this trace here. And as you can see, there are three tantalum capacitors on this 12-volt rail, and any one of those can be short circuit. So I finally removed the last one, and of course the last one was the one which was causing the short. And here we have the three tantalum capacitors, so I'm just going to be checking their resistance to see if there are any short circuits. And two of the tantalum capacitors check out fine, but the third one does in fact have a short circuit. So we need to replace that one. So as I don't have any spare tantalum capacitors, I'm going to be using this electrolytic capacitor, which should also do the job just fine. So I'm just going to be adding it here. And after that, we can check with our multimeter that there are no more shorts on the 12-volt rail. So while I have the floppy drive disassembled, I can just as well clean the heads a little bit. So I'm going to be taking some isopropyl alcohol and clean the read-write heads like so. And then it's time to put the PCB back on the floppy drive, hook up all of the connectors, and do a final test on the computer to see if it actually works. So let's insert a floppy disk here and see if we can access it. So I'm just going to go through the drive letter A. So let's see if we can bring up the directory listing, and here it comes, which is good. Let's do a thorough test and try to copy all of the files into a temporary folder on the hard drive, just to make sure that it is able to read an entire disk. And it has passed this test with flying colors. So the floppy drive has been fixed. So next up, the CGA card with the shorted 12-volt rail. Now this is a common problem on the CGA card, and it's even more common that this capacitor here is going short circuit, and this is going to be the case here. So the simple fix would be just to remove it, install a new capacitor, and everything should be fine, right? Well, not exactly. So I actually desoldered the capacitor, checked that it was indeed short circuit. I inserted a new one, but the problem remained. When I started the PC with this CGA card, I got the long beep followed by the two short beeps, indicating there was still an issue with the video card. Now I do have a spare CGA card, so I had enough hardware here to do comparisons, check values. Everything seemed to check out, even on the faulty CGA card. I didn't find any shorts. There are obviously lots of capacitors on the CGA card. I checked pretty much all of them. I desoldered them. I checked them using an ESR meter, and I didn't find any issues with it. So it remains a mystery to me why the card is not working. There is one seated chip on the card. I also replaced that one, but it just fails to start for some reason, making it very difficult. So up until now I have no idea why the card is not working. So I ended up replacing all of the capacitors, but nothing worked. So the card remains dead. And then out of nowhere this started happening. Weird noises coming from the PC speaker indicating some kind of issue with the keyboard. At one point the keyboard just decided to write stuff on its own, so there was probably something wrong with the connection, either on the keyboard itself or somewhere on the connection to the main board. And all of a sudden the keyboard went completely dead, not responding to any keystrokes anymore, giving me yet another reason to open up another piece of IBM equipment, this Model F keyboard. To open the keyboard, we need to remove the plastic front covers by gently pushing down on these little tabs here so that we can open it up. So make sure not to break off these clips, and then we can take this top part off. The keyboard is held in place by two screws. This is the most heavy part of the keyboard, and here we have the sheet of plastic. The keyboard connector here is hidden beneath this thing. We need to remove this screw which is pretty oxidized for some reason. So here we have the keyboard connector on the keyboard itself, and the connector itself was a little bit dirty, so I did clean it off a little bit, reinserted the connector, and after that the keyboard started working fine again. So moving on to this bad boy over here, which is the quad board. This features 6 memory banks, a VARTA rechargeable battery. The card also features this game port and a parallel port. And on the card itself, we have a 25-pin serial port and some dip switches for the configuration. The documentation for the quad board can be easily found online, giving you some background information on the card and the features that it provides. So it has a serial port. It can provide up to 384 kilobytes of additional RAM. It provides parallel port, and you use these dip switches and jumpers to configure the card. Now, in this particular case, all of the 6 memory banks have been completely filled with 384 kilobytes of RAM. However, the PC still only recognized 256 kilobytes, which is the total memory which is on the main board. So we need to investigate why. All of the jumpers are set correctly, but we do, of course, have the battery issue that might have caused some bad traces. So we'll start by removing the 2 connectors here for the game port and the parallel port. And now we can take a look at the battery situation. Now this battery was used to preserve the date time settings on the PC, obviously, but in this case we are going to be removing the battery because we want to see what's beneath this battery and how much damage it has caused. Because as you can see on the back side of the card itself, there is a lot of corrosion here from the battery. So I'm just going to be desoldering the battery pins and getting the battery out so that we can check the damage. So to remove this corrosion, I'm going to be using some white vinegar using this Q-tip. I'm just going to put it on the affected area, and you will immediately see that it starts doing its thing, and it will clean up the PCB quite nicely. Obviously, if there are traces that were damaged because of the battery leakage, we will need to fix those. We'll do the same thing on the back of the card, where we also have some damage. And again, the white vinegar is doing its job very well, and the traces become more visible that might have been impacted. So we'll need to do some continuity checks here to make sure that the traces are still intact, and for the traces that aren't intact anymore, we will need to repair them. Now, while I'm in cleaning mode, I'm also going to be using some isopropyl alcohol to clean the ISA slot connectors of the card. And I'm also going to remove some of the RAM chips to see what the condition of the sockets is, and just to make sure that there isn't any corrosion and that the RAM chips are making a firm connection, which appears to be the case. There is a very small amount of corrosion. So I'll be using some contact cleaner to clean everything. To check for bad traces, you need to be able to follow them, and that's not always that easy, especially because there are 2 sides to this board, and oftentimes these traces will go from one side to another. Now, if you place the board in front of a well-lit environment, you will be able to see the traces a lot better, and you will be able to follow them more closely. Now, I've inspected all of the traces here, and I only found one trace that needed repairing, and it was for the game port. So that couldn't explain why the system wasn't finding our additional memory. Now, all of the dip switches were set in the correct position, but I did notice that it was kind of hard to switch them. And I also noticed that although some dip switches were in the on position, meaning that they should provide continuity between the 2 pins here, that some dip switches which were on the on position did not provide continuity. And importantly, the dip switch for enabling the memory didn't provide any continuity. So that was probably the reason why it did not find the card. Now, sometimes these switches can get stuck, or there can be some corrosion inside or beneath the switch block. So I'm just going to try and switching them on and off again using this screwdriver here, just to make sure that they make a firm contact, and checking the continuity afterwards. But there was still no continuity, so the particular switch that enables the memory seems to be faulty. And if you look closely beneath the switch block, you do see some corrosion on these pins. So ideally we'll need to replace this switch block completely. Now I don't have a spare switch block now. I want to move this project ahead. So what I'm going to be doing is I'm going to be short-circuiting the switch to enable the memory directly using a piece of wire so that the additional memory will be enabled and we can verify if the machine will actually detect the additional memory. So as it's counting upwards, it reaches the critical path of 256 kilobytes, and it does in fact continue counting all the way up to 640K, which is very nice. So the time has come to put all of the components back into the computer, starting with the hard drive here, which goes into the bottom 5 1/4 inch tray of the computer. So it slides in like so. And the same for the floppy drive. We need to slide it in from the back like so, put it in the appropriate position, and then insert all of the expansion cards, starting with the CGA card, the connector on the CGA card to hook up the internal display of the computer. Here we have our RAM expansion card. We have the floppy drive controller. We'll need to do some cable management here also because it's very tight in here. We have the RLL hard drive controller, which also needs 2 cables to hook up the hard drive. Everything should work on the PC right now. So I'm going to copy some files over to the hard drive just to fill it up nicely, install lots of software on it so that I can verify that the machine works properly and that the hard drive doesn't produce any errors. And I'll show you the outcome of that in what should be the final part of this IBM 5155 adventure we have been having here. Thanks a lot for watching. Make sure to hit that subscribe button. Feel free to comment, share, and I hope to see you guys soon. Bye bye.